super chip server. This is just a CPU. And it has the ability to accommodate 4 Grace CPUs or 2 Grace super chips, enormous amounts of performance. And if your data center is power limited, this CPU has incredible capabilities. In a power limited environment, running PageRank, and there's all kinds of benchmarks you can run, but we ran PageRank in ISO performance. Grace only consumes 580 watts for the whole server, versus the latest generation CPU servers, x86 servers, 1,090 watts. It's basically half the power at the same performance. Or another way of saying, at the same power, if your data center is power constrained, you get twice the performance. Most data centers today are power limited. And so this is really a terrific capability. There are all kinds of different servers that are being made here in Taiwan. Let me show you one of them, get my exercise in today. Whoosh. I am the sound effect. Okay. You've got BlueFlu 3, you've got the CX7, you've got the Grace Hopper. There's so many systems. Let me show you some of them. All of our partners, I'm so grateful. You're working on Grace, Grace Hopper, L40s, L4s, BlueField 3s. Just about every single processor that we're building are configured into these servers of all different types. And so this is super micro, this is gigabyte, tens, I think it's like 70 different server configurations. This is Ingresses, this is ASRock, Tyann, Wistron, Inventec, just beautiful servers, Pegatron. We love servers, I love servers, they're beautiful. They're beautiful to me. QCT, ASUS, we win. ZT Systems, and this ZT system, what you're looking at here is one of the pods of our Grace Hopper AI supercomputer. So I want to thank all of you. I want to thank all of you for your great support. Thank you. We're going to expand AI into a new territory. If you look at the world's data centers, the data center is now the computer, and the network defines what that data center does. Largely, there are 2 types of data centers today. There's the data center that's used for hyperscale, where you have application workloads of all different kinds. The number of CPUs, the number of GPUs you connect to it is relatively low. The number of tenants is very high. The workload is heterogeneous. The workloads are loosely coupled. And you have another type of data center. They're like supercomputing data centers, AI supercomputers, where the workloads are tightly coupled. The number of tenants, far fewer, and sometimes just one. Its purpose is high throughput on very large computing problems. Okay? And it's basically a standalone. It's basically a standalone. And so supercomputing centers and AI supercomputers and the world's cloud, hyperscale cloud, are very different in nature. Ethernet is based on TCP. It's a lossy algorithm, and it's very resilient. And whenever there's a loss, packet loss, it retransmits. There's error correction that's done. It knows which one of the packets are lost and requests the sender to retransmit it. The ability for Ethernet to interconnect components of almost from anywhere is the reason why the world's internet was created. If it required too much coordination, how could we have built today's internet? So Ethernet's profound contribution, it's this lossy capability, it's resilient capability, and because so, it basically can connect almost anything together. However, a supercomputing data center can't afford that. You can't interconnect random things together because that billion-dollar supercomputer, the difference between 95% networking throughput achieved versus 50% is effectively $500 million. So the cost of that one workload running across that entire supercomputer is so expensive that you can't afford to lose anything in the network. InfiniBand relies on RDMA very heavily. It is a flow control. It's a lossless approach. It requires flow control, which basically means you have to understand the data center from end to end, the switch to the NIC to the software, so that you can orchestrate the traffic with adaptive routing, so that you could deal with congestion control and avoid the oversaturation of traffic in an isolated area, which results in packet loss. You simply can't afford that because in the case of InfiniBand, it's lossless. And so one is lossy, the other one's lossless. Very resilient, very performant. These two data centers have lived separate lives. These two data centers have lived separate lives. But now, we would like to bring generative AI to every data center. The question is how? The question is, how do we introduce a new type of Ethernet that's, of course, backwards compatible with everything, but is engineered in a way that achieves the type of capabilities that we can bring AI workloads to the world's any data center. This is a really exciting journey. And at the core of this strategy is a brand new switch that we've made. This is the Spectrum 4 switch. And this switch everything I'm showing today are very heavy. Whoosh, like that. This is the Spectrum 4 switch, 128 ports of 400 gigabits per second, 128 ports of 400 gigabits per second, 51.2 terabits per second. This is the chip. It's gigantic. 100 billion transistors, 90 millimeters by 90 millimeters, 800 balls on the bottom. This is a 500-watt chip. This switch is 2,800 watts. It's air-cooled. There are 48 PCBs that connect the switch together. 48 PCBs that build up the switch. And this switch is designed, to, This switch is designed to enable a new type of Ethernet. Remember what I said. InfiniBand is fundamentally different in the sense that we build InfiniBand from end to end so that we could do adaptive routing, so that we could do congestion control, so that we could isolate performance, so we could keep noisy neighbors apart, so that we could do in-fabric computing. All of these capabilities are simply not possible in a lossless approach of the internet, and of course, of Ethernet. And so the way that we do InfiniBand is design it from end to end. This is the way supercomputers are built. This is the way AI supercomputers are built. And we are going to do the same thing now for the very first time for Ethernet. We've been waiting for the critical part, and the critical part is the Spectrum 4 switch. The entire system consists of several things. So our new Ethernet system for AI, is this. The Spectrum 4 switch and the Bluefield 3 Smart NIC or DPU. This Bluefield 3 is 400 gigabits per second NIC. It connects directly to the Spectrum 4 switch in combination of four things: the switch, the Bluefield 3, the cablings that connect them together, which are super important, and the software that runs it all together represents the Spectrum 4. This is what it takes to build a high-performance network, and we're going to take this capability to the world's CSPs. The reception has been incredible, and the reason for that is, of course, every CSP, every data center would like to turn every single data center into a generative AI data center. There are some people that they deployed Ethernet throughout their company, and they have a lot of users for that data center. The ability to have the capabilities of InfiniBand and isolating it within their data center is very difficult to do. And so for the very first time, we're bringing the capabilities of high-performance computing into the Ethernet market. And we're going to bring to the Ethernet market several things. First, adaptive routing. Adaptive routing basically says, based on the traffic that is going through your data center, depending on which one of the ports of that switch is over-congested, it will tell BlueField 3, and it will send it to another port. BlueField 3 on the other end would reassemble it and present the data to the CPU, present the data to the computer, to the GPU, without any CPU intervention, all completely in RDMA. Number one, adaptive routing. Second, congestion control. Congestion control, it is possible for certain different ports to become heavily congested, in which case the telemetry of the switch, each switch will see how the network is performing and communicate to the senders, please don't send any more data right away because you're congesting the network. That congestion control requires basically an overriding system, which includes software, the switch, working with all of the endpoints to overall manage the congestion or the traffic and the throughput of the data center. Now, it's really important to realize that in a high-performance computing application, every single GPU must finish their job so that the application can move on. In many cases where you do all reductions, you have to wait until the results of every single one. So if one node takes too long, everybody gets held back. This capability is going to increase Ethernet's overall performance dramatically. So Spectrum-X, really excited to roll this out. The world's applications, the world's enterprise has yet to enjoy generative AI. So far, we've been working with CSPs. And this CSPs, of course, is going to be able to bring generative AI to many different regions and many different applications and industries. The big journey is still ahead of us. There are so many enterprises in the world, and everybody, because of the multimodality capability that I was mentioning before, every industry can now benefit from generative AI. There's several things that we have to do. Number one, we have to help the industries build custom language models. Not everybody can use the language models that are available in a public service. Some customers need language models that are highly specialized for their particular modality. For example, proteins or chemicals. Each one of these industries have proprietary information. And so how can we help them do that? We have created a service called NVIDIA AI Foundation. It is a cloud service that captures NVIDIA's AI expertise and makes it possible for you to train your own AI models. We will help you develop your own AI models with supervised fine-tuning, with guardrailing, with proprietary knowledge bases, and reinforcement learning human feedback so that this AI model is perfect for your application. We then deploy this model to run on NVIDIA AI Enterprise. This is the operating system that I was talking to you about earlier. This operating system runs on every single cloud. This allows this very simple system with NVIDIA AI Foundation for training large language models and deploying the language model into NVIDIA AI Enterprise, which is available in every single model, every single cloud and on-prem, allows every single enterprise to be able to engage. Now, one of the things that very few people realize is that today, there's only one software stack that is enterprise secure and enterprise grade. That software stack is CPU. And the reason for that is because in order to be enterprise grade, it has to be enterprise secure, it has to be enterprise managed, and enterprise supported across its entire life, across its life cycle. There are so much software in accelerated computing. Over 4,000 software packages is what it takes for people to use accelerated computing today in data processing and training and optimization all the way to inference. So for the very first time, we are taking all of that software and we're going to maintain it and manage it like Red Hat does for Linux NVIDIA AI Enterprise will do it for all of NVIDIA's libraries. Now, enterprise can finally have an enterprise-grade and enterprise-secure software stack. This is such a big deal. Otherwise, even though the promise of accelerated computing is possible for many researchers and scientists, it's not available for enterprise companies. And so let's take a look at the benefit for them. This is a simple image processing application. If you were to do it on a CPU versus on a GPU running on enterprise, NVIDIA AI Enterprise, you're getting 31.8 images per minute, or basically 24 times the throughput, or you only pay 5% of the cost. This is really quite amazing. This is the benefit of accelerated computing in the cloud. But for many companies, enterprises, it's simply not possible unless you have this stack. NVIDIA AI Enterprise is now fully integrated into AWS, Google Cloud, and Microsoft Azure and Oracle Cloud. And so when you go and deploy your workloads in those clouds and you want software that is enterprise grade, or if you have customers that need enterprise grade software, NVIDIA AI Enterprise is ready for you. It is also integrated into the world's machine learning operations pipeline. As I mentioned before, AI is a different type of workload, and this new type of software has a whole new software industry. And this software industry, 100% of them, we have now connected with NVIDIA AI Enterprise. Now let me talk to you about the next phase of AI, where AI meets a digital twin. Now why does AI need a digital twin? I'm going to explain that in just a second. But first, let me show you what you can do with it. In order for AI to have a digital twin, in order for AI to understand heavy industry, remember, so far, AI has only been used for light industry, information, words, images, music, so on and so forth. If we want to use AI for heavy industry, the $50 trillion of manufacturing, many of you're part of, the trillions of dollars of healthcare, all of the different manufacturing sites, whether you're building chip fabs or battery plants or electric vehicle manufacturing factories, all of these would have to be digitized in order for artificial intelligence to be used to automate, to design, to build, and to automate the future of your business. And so the first thing that we have to do is we have to create the ability for their world to be represented in digital. Okay, so number one is digitalization. Well, how would you use that? So let me give you just a simple example. In the future, you would say to your robot, I would like you to do something, and the robot will understand your words, and it would generate animation. Remember, I said earlier, you can go from text to text. You can go from text to image. You can go from text to music. Why can't you go from text to animation? And so, of course, in the future, robotics will be highly revolutionized by the technology we already have in front of us. However, how does this robot know that the motion that it is generating is grounded in reality? It is grounded in physics. You need a software system that understands the laws of physics. Now, you've actually seen this already with ChatGPT. Whereas AI, NVIDIA AI, would use NVIDIA Omniverse as in a reinforcement learning loop to ground itself, you have seen ChatGPT do this using reinforcement learning human feedback. Using humans' feedback, ChatGPT was able to be developed by grounding it to humans' sensibility and align it with our principles. So reinforcement learning with human feedback is really important. Reinforcement learning for physics feedback is very important. Let me show you everything that you're about to see is a simulation. Let's roll it, please. everything was a simulation. Nothing was art. Everything was simulation. Isn't that amazing? In the last 25 years, I come to Taiwan, you sell me things. Omniverse will be the first thing I'm going to sell you. And this, because this will help you revolutionize your business and turn it into a digital business and automate it with AI. You will build products in digital first before you make it physical. You will build factories and plan it in digital first before you make it in physical. And so, in the future, Omniverse is a very big deal. Now, I'm going to show you very quickly Omniverse in the cloud. Omniverse, the entire stack is so complicated. And so we put the whole thing into a cloud managed service, and it's hosted in Azure. This particular experience you're going to have, the computer is in California. And Sean? I'm sorry I took so much time, so you're going to have to...
We'll go quick. So this is, let's take a look at the Omniverse Cloud. So this is, just a web browser, and we're looking now into Omniverse Factory Explorer. It's running 10,000 kilometers away in our Santa Clara headquarters, and we're leveraging the power of our data center now to visualize this factory floor. We're using real factory data from Siemens and Autodesk Revit to take a look. It's a cloud application, so we can have multiple users collaborating. Let's go ahead and bring up Eloise's screen, and we can see that we have these two users in this environment. And Jeff on the left there is going to look at some markup. We have this task to perform. We need to move this object. So we can have Eloise just go ahead and grab that conveyor belt, move it over, and as he does so, you'll see that it's reflected accurately and completely in real time on Jeff's screen. So we're able to collaborate with multiple users, and even in bringing up this demo, we had users from around the globe working on the process. East and West Coast, United States, Germany, even Sydney, and of course here in Taipei, to put this together. Now, if we're modifying our production line, of course, one of the things we want to do is add the necessary safety equipment. So we're able to simply drag and drop items into Omniverse and modify this production environment and begin tweaking this and optimizing for performance even before we break ground with construction.
Your turn to ban. 5 seconds remaining.
That is so cool. This is in California, 6,264 miles away, or something like that. 34 milliseconds by speed of light one way. And it's completely interactive. Everything is ray traced. No art is necessary. You bring everything, the entire CAD into Omniverse, open up a browser, bring your data in, bring your factory in. No art is necessary. The lighting just does what the lighting does. Physics does what the physics does. If you want to turn off physics, you can. If you want to turn on physics, you can. And multiple users, as many as you like, can enter the Omniverse at the same time and work together.
5 seconds remaining.
One unified source of data across your entire company. You could virtually build, you could virtually design and build and operate your factory before you break ground and not make the mistake which usually in the beginning of the integration creates a lot of change orders, which costs a lot of money. Thank you very much, Sean. Good job. Not only, notice just now, it was humans interacting with Omniverse. Humans interacting with Omniverse. In the future, Sean will even have a generative AI, and AI interact with him in Omniverse. We could, of course, imagine in the very beginning there was Jin. That could be a character. That could be one of the users of Omniverse interacting with you, answering questions, helping you. We can also use generative AI to help us create virtual worlds. So for example, this is a bottle that's rendered in Omniverse. It could be placed in a whole bunch of different type of environments. It could render beautifully physically. You could place it just by giving it a prompt, by saying, I would like to put these bottles in a lifestyle photograph style backdrop of modern, warm farmhouse bathroom. Change the background. Everything is all integrated and rendered again. Okay, so Generative AI will come together with Omniverse to assist the the creation of virtual worlds.
The battle begins.
Today, we're announcing that WPP, the world's largest advertising agency and advertising services company, is partnering with NVIDIA to build a content generation engine based on Omniverse and generative AI. It integrates tools from so many different other partners, Adobe Firefly, for example, Getty, Shutterstock, and it integrates into this entire environment. And it makes it possible for them to generate unique content for different users for ad applications, for example. So in the future, whenever you engage a particular ad, it could be generated just for you. But yet, the product is precisely rendered because, of course, the product integrity is very important. And so every time that you engage a particular ad in the future, today, it was retrieved. And today, the computing model, when you engage information, it is retrieved. In the future, when you engage information, much of it will be generated. Notice the computing model has changed. WPP generates 25% of the ads that the world sees. 60% of the world's largest companies are already clients. And so they made a video of how they would use this technology.
The world's industries are racing to realize the benefits of AI. NVIDIA and WPP are building a groundbreaking, generative AI-enabled content engine to enable the next evolution of the $700 billion digital advertising industry. Built on NVIDIA AI and Omniverse, this engine gives brands the ability to build and deploy highly personalized and compelling visual content faster and more efficiently than ever before. The process starts by building a physically accurate digital twin of a product using Omniverse Cloud, which connects product design data from industry-standard tools. Then, WPP artists create customized and diverse virtual sets using a combination of digitized environments and generative AI tools by organizations such as Getty Images and Adobe, trained on fully licensed data using NVIDIA Picasso. This unique combination of technologies allows WPP to build accurate photorealistic visual content and e-commerce experiences that bring new levels of realism and scale to the industry.
Quick up. No problem. We continue. Okay, so that's WPP. You could see that that was an example. If you think about it a second, that's an example of a company using digital information that was created in design and using that digital information all the way in marketing. I'm going to show you now how we're going to use Omniverse and AI here in Taiwan. And we're going to use it for manufacturing. Manufacturing, as you know, is one of the largest industries in the world. We're going to use Omniverse to teach an AI. And then we're going to use Metropolis, our AI deployment, edge deployment system, to deploy the AI. Okay, run it.
The $45 trillion global manufacturing industry is comprised of 10 million factories operating 24/7. Enterprises are racing to become software-defined to ensure they can produce high-quality products as quickly and cost-efficiently as possible. Let's see how electronics manufacturer Pegatron uses NVIDIA AI and Omniverse to digitalize their factories. In Omniverse, they start by building a digital twin of their factory, unifying disparate 3D and CAD datasets to provide a real-time view of their complex factory data to their planners and suppliers. In the cloud-native digital twin, planners can then optimize layout virtually before deploying changes to the real factory. The digital twin is also used as a training ground and data factory for Pegatron's perception AIs. They use NVIDIA Isaac Sim, built on Omniverse, to simulate and optimize their fleet of mobile robots, which help move materials throughout the facility, as well as the pick-and-place robotic arms that assist on production lines. In the fully operational factory, Pegatron deploys automated optical inspection, or AOI points, along their production lines, which reduces cost and increases line throughput. NVIDIA Metropolis enables Pegatron to quickly develop and deploy cloud-native, highly accurate AOI workflows across their production lines. Omniverse Replicator generates synthetic datasets of PCBA defects, which are too complex and costly to capture in the real world, like scratches and missing or misaligned components. Pegatron then combines the synthetic data with NVIDIA pre-trained models, NVIDIA Tau for training, adaptation, and optimization, and NVIDIA DeepStream for real-time inference, resulting in AOI performance that is 99.8% accurate with a 4 times improvement in throughput. With software-defined factories built on NVIDIA AI and Omniverse, manufacturers can super accelerate factory bring-up and minimize change orders, continuously optimize operations, maximize production line throughput, all while reducing costs.
Did you see that? The whole factory is an Omniverse. It's completely digital. Imagine if you have digital information in your hands, what can you do with it? Almost everything. And so this is one of the things that's really exciting. What you just saw is basically every factory in the future will be digital, of course, first. Every factory will be a robot. Inside the factories, there will be other robots that the factory is orchestrating. We are also going to build robots that move themselves. So far, the robots that you saw are stationary. Now we're going to also have robots that move. Everything that moves in the future will have artificial intelligence and will have robotic capability. And so today we're announcing our robot platform, NVIDIA Isaac AMR, is now available as a reference design for anybody who wants to build robots. Just like we did with our high-performance computing. NVIDIA builds the whole stack. And then we disaggregate it so that if you would like to buy the chip, that's fine. If you like to buy the system, that's fine. If you like to use your software, that's fine. If you like to use our software, that's fine. If you like to use your own algorithm, that's terrific. If you like to use ours, that's terrific. However you would like to work with us, we're open for business so that we can help you integrate accelerated computing wherever you like. In the future, we're going to do the same with robotics. We built the entire robotic stack top to bottom, from the chip to the algorithms. We have state-of-the-art perception for multimodality sensors, state-of-the-art mapping, state-of-the-art localization and planning, and a cloud mapping system. Everything has been created. However you would like to use it, you can use pieces of it. It's open available for you, including all the cloud mapping systems. So this is Isaac AMR. It starts with a chip called Orin. It goes into a computer, and it goes into the NVIDIA Nova Orin, which is a reference system, a blueprint for AMRs. This is the most advanced AMR in the world today. And that entire stack has been built, and let's take a look at it.
To improve productivity and increase worker safety, factories and warehouses are migrating away from manual forklifts and guided vehicles to full autonomy. NVIDIA Isaac AMR provides an integrated end-to-end solution to deploy fully autonomous mobile robots. The core of the solution is Nova Orin, a sensor suite and computing hardware that enables mapping, autonomy, and simulation. Nova's collection of advanced sensors speeds the mapping process, leveraging our cloud-based service to generate an accurate and detailed 3D voxel map. This 3D map can then be sliced across a plane to generate 2D maps tailored for different autonomous robots that might operate in a facility. With these maps in place, on-robot LiDAR or cost-effective cameras provide autonomous navigation that works reliably in the most complex and dynamic environments. Isaac Mission Control optimizes route planning using the cuOpt library. To improve operations, developers can use Isaac Sim and NVIDIA Omniverse to create realistic digital twins of the operating environment. This allows fully autonomous robots to be trained on complex tasks entirely in simulation. All operations can be fully validated using Isaac Sim before deployment to the real world. Isaac AMR accelerates your migration to full autonomy, reducing costs and speeding deployment of the next generation of AMRs.
Nova cannot tell that it is not in the reality environment. Nova thinks it is in the real environment. It cannot tell. And the reason for that is because all the sensors work, physics work, it can navigate, it can localize itself. Everything is physically based. So therefore we could design, therefore we can design the robot, simulate the robot, train the robot, all in Isaac, and then we take the brain, Isaac Sim, then we take the brain, the software, and we put it into the actual robot. And with some amount of adaptation, it should be able to perform the same job. This is the future of robotics. Omniverse and AI working together. The ecosystem that we have been in, the IT ecosystem, is $250 billion per year, $250 billion a year. This is the IT industry. For the very first time in our history together, we finally have the ability to understand the language of the physical world. We can understand the language of heavy industry. And we have a software tool, we have a software system called Omniverse that allows us to simulate, to develop, to build and operate our physical plants, our physical robots, our physical assets as if they were digitally. The excitement in the hard industries, the heavy industries, has been incredible. We have been connecting Omniverse all over the world with tools companies, robotics companies, sensor companies, all kinds of industries. There are 3 industries right now as we speak that's putting enormous investments into the world. Number 1, of course, is chip industry. Number 2, electric battery industry. Number 3, electric vehicle industry. Trillions of dollars will be invested in the next several years. Trillions of dollars will be invested in the next several years. And they would all like to do it better, and they would like to do it in a modern way. For the very first time, we now give them a system, a platform, tools that allows them to do that. I want to thank all of you for coming today. I talked about many things. It's been a long time since I've seen you, so I had so much to tell you. It was too much. It was too much. Last night I said, this is too much. This morning I said, this is too much. And now I realize it's too much. I told you several things. I told you that we are going through 2 simultaneous computing industry transition, accelerated computing and generative AI. 2, this form of computing is not like the traditional general purpose computing. It is full stack. It is data center scale because the data center is the computer, and it is domain specific. For every domain that you want to go into, every industry you go into, you need to have the software stack. And if you have the software stack, then the utility, the utilization of your machine, the utilization of your computer will be high. So number 2, it is full stack data center scale and domain specific. We are in full production of the engine of generative AI, and that is HGX H100. Meanwhile, this engine that's going to be used for AI factories will be scaled out using Grace Hopper, the engine that we created for the era of generative AI. We also took Grace Hopper and realized that we can extend, on the one hand, the performance, but we also have to extend the fabric so that we can make larger models trainable. And we took Grace Hopper, connected to 256 node NVLink, and created the largest GPU in the world, DGX GH200. We're trying to extend generative AI and accelerated computing in several different directions at the same time. Number 1, we would like to, of course, extend it in the cloud so that every cloud data center can be an AI data center. Not just AI factories and hyperscale, but every hyperscale data center can now be a generative AI data center. And the way we do that is the Spectrum X. It takes 4 components to make Spectrum X possible: the switch, the the BlueField 3 NIC, the interconnects themselves. The cables are so important in high-speed communications, and the software stack that goes on top of it. We would like to extend generative AI to the world's enterprise. And there are so many different configurations of servers, and the way we're doing that with partnership with our Taiwanese ecosystem, the MGX Modular Accelerated Computing Systems. We put NVIDIA in the cloud so that every enterprise in the world can engage us to create generative AI models and deploy it in a secure way, in a enterprise-grade, enterprise-secure way in every single cloud. And lastly, we would like to extend AI to the world's heavy industries, the largest industries in the world. So far, our industry that all of us have been part of, has been a small part of the world's total industry. For the very first time, the work that we're doing can engage every single industry. And we do that by automating factories, automating robots, and today we even announced our first robotics full reference stack, the Nova Orin. I want to thank all of you for your partnership over the years. Thank you.
I hope that you do like me best. Now my song's in a long thank you from NVIDIA.
This podcast is brought to you by the Minis Forum NPB7 Mini PC. Click the link in the description to support Moore's Law Z and check out that fantastic micro workstation, but also support Moore's Law is Dead by using the offer code BROKENSILICON for 10% off Vite Ramen, or the offer code BROKENSILICON for 25% off all Windows keys at cdkeyoffer.com. You can also use DieShrink to get 3% off everything else on that website, and we'll talk about these supporters later. But for now, let's just get on with the show. Welcome to Broken Silicon, a gaming hardware podcast. I am your host, Tom, and today I am joined by someone who's coming on for the third time, I believe. The last episode especially actually is performing incredibly well. I think that one turned out great, and I have no reason to think this one won't again. And I'm sure a lot of the people watching this saw the title, know who you are. I'm sure we share a lot of the same fans, but please, for someone who's stumbled in here, hasn't heard of Adored TV before, please introduce yourself.
All right, guys, how's it going? It's Jim from Adored TV. As Tom said, I was on the show a few months ago, and yes, it was a pretty popular podcast. In fact, I noticed it's over 150,000 views last time I checked, so that one went down very well, in fact. I'm pretty similar to Tom in that I run my own, my Adored TV YouTube channel. I guess you could call me an analyst of sorts. It's kind of what maybe the major component of my YouTube channel.
Well, let's say you're at like a dinner party or something, or a friend introduced you to another friend. Yeah. What do you call yourself? Because I struggle with that. I mean,
funnily
you
enough,
say YouTuber, they think you're doing something entirely different than what you're really doing.
And they just assume that you've maybe got like 500 subscribers and like literally nobody watches you as well. Normally, I introduce myself as, to be honest, these days, I either say YouTuber and stock trader, which is something that I'm doing quite a lot of and have been for the past year and a half, or I will say ex-YouTuber, because to be honest with you, compared to my like previous output of previous years, there's no question that I just don't quite have the same motivation, and although I'm still very interested in it, I'm kind of releasing videos because I feel like people miss me. So I feel a bit kind of guilt-tripped into releasing videos back and forward. I do still enjoy it, but I much more enjoy it once the video is finished with and I can get back to concentrating on other things, if I'm being completely honest with you. But maybe it'll come back. Yeah, I am sort of hoping that this whole AI thing, which looks like it is really taking off now, this is something that I am obviously very interested in. If you ever saw my, did you watch my Singularity video? The Singularity, it was the one with Elon Musk and stuff like that. And I mean, it only
that
got
was a while ago, right?
It was a couple of years ago anyway. It got like
I think so. It sounds
views.
familiar to me, but that was a bit ago, so I don't remember the specifics.
I mean, anytime I do one of these sort of videos where it might be tech focused, but it's not directly focusing on the, you know, the Trinity, AMD, NVIDIA, or Intel, they just don't do that well. And whenever I do any other kind of science videos, they don't. I mean, 30,000 views is sort of like bang on, which these videos get. Whereas I know that my typical video is probably going to hit 50, 60, 70,000. So I do these out of the pure love of the subject, basically. Yeah. Not that to be
Super chip server. This is go up and talk to this character. And because this character has been infused with artificial intelligence and large language models, it can interact with you, understand your meaning, and interact with you in a really reasonable way.
Copilots and AI applications. And AMD just held their own data center and AI technology premiere where they showcased hardware and software solutions for this massive wave of AI innovation. And of course, we should also check in with Intel. Good job, Intel. All kidding aside, the AMD presentation made it crystal clear just how far ahead NVIDIA is, and I'll explain exactly why that's a big problem in a minute. I made supercuts for each of these events, and I did my best to highlight the most important parts in as little time as possible. So, if you haven't checked them out yet, I put them all in one convenient playlist for you, which I'll also leave in the description. They have over 3 million combined views so far, so I won't rehash them here. But if you did watch them, then you know that there's one presentation that completely blew the rest out of the water, and that's NVIDIA's keynote at Computex in Taipei. NVIDIA's CEO Jensen Huang revealed product after product and service after service set to dominate the entire AI stack. He showed that if data centers switch from Intel and AMD's CPUs to NVIDIA's GPUs, they can do 44 times more work while using less than 1/3 the power.
The GPU server is no longer the computer. The computer is the data center. Your goal is to build the most cost-effective data center, not build the most cost-effective server. Back in the old days when the computer was the server, that would be a reasonable thing to do. But today, the computer is the data center. So for $10 million, you buy 48 GPU servers. It only consumes 3.2 gigawatt hours and 44 times the performance. Let me just show it to you one more time. This is before, and this is after, and this is...
Said a different way, if a data center switches to NVIDIA's new DGX H100 GPU systems, they could do around 150 times the work with the same amount of power, or power the same sized large language model for just around 4% of the cost. And that's just the beginning. Jensen also showed off the Grace Hopper Superchip, which lets NVIDIA compete directly with AMD and Intel for more CPU-heavy data center workloads. Then he showed off new networking technologies like their NVLink and InfiniBand to connect hundreds of these superchips to effectively create one supercomputer-sized GPU. And he also showed off tons of software that NVIDIA's built on top of all this hardware, and how it can already power massive large language models and AI avatars for a wide variety of applications. Everything from retail and customer service to manufacturing and robotics, and even video games and movies are going to benefit from this tech stack. And here's what AMD showed off just 2 weeks later.
So let's watch, for the first time ever, MI300X running Falcon on a single GPU accelerator. We have to give the model a prompt, so we are here in San Francisco. Let's say, write a poem about San Francisco. Here we go, the poem's coming. You can see it's responding in real time. I'm not a great poet, I don't know about you guys. I would say that poem's pretty good, huh?
Believe it or not, the poem thing was actually a lot more impressive than it looked. What AMD was actually showing off there was that they could run an entire 40 billion parameter model on one single AMD Instinct GPU. The problem here is there's nothing really stopping that same model from working on the equivalent NVIDIA GPU either. But the bigger problem is just how obviously rushed AMD's presentation was. how little time they spent covering new chip designs or software solutions for AI development at all, and how much of their talk focused on the dangers of one vendor controlling the entire AI ecosystem. That vendor is, of course, NVIDIA. By the way, if you want a great app for stock market research and investing, check this out. Here's NVIDIA's company page. It's full of useful info like what industries and markets they compete in, analyst ratings, and even their top shareholders. And if I click financials, I can see NVIDIA's latest earnings, their revenue breakdown, analyst expectations, and plots tracking every important indicator I can think of, all in one convenient place. This is why I think Moomoo is a great app for more advanced investors. And right now, they're giving away up to 15 free stocks, each valued at up to $2,000, plus a $100 cash bonus and a free share of C3 AI when you use my link to sign up, and a share of Tesla or Google when you deposit at least $5,000. If you're trying to invest in AI, all these free stocks are a no-brainer. All you need to do is download the app using my link, keep your account funded at that level for at least 60 days, and enjoy up to 17 free stocks. But this offer ends soon, so make sure to get started today. Alright, AMD's presentation had about 50 times fewer views than NVIDIA's, which means a lot of things are going unnoticed. Because AMD's presentation was so rushed, they ended up revealing just how far behind NVIDIA they really are. Let me quickly show you a few of their biggest slip-ups.
Early on in our partnership, we had concerns about
We were new.
About AMD's ability to scale alongside us and meet our demand.
And it's especially exciting for me, not only because now we've really put all the focus of the company under one roof, the data center GPU team, and our newly formed AI group.
When we try to size it, we think about the data center AI accelerator TAM growing from something like $30 billion this year, over 50% compound annual growth rate, to over $150 billion in 2027. And it may be higher, it may be lower. But what I can say for sure is it's going to be a lot.
So Meta Platforms had concerns about their partnership with AMD and their ability to scale. AMD admitted that their AI team is brand new, and Lisa Su seems not to really be sure how big the market for AI accelerators is even going to be in the first place. And that's just the stuff that actually made it into the presentation. By the way, I'm not showing you these clips to hate on AMD. I'm a longtime shareholder and a longtime fan of their CPUs. What I'm trying to show you is just how far ahead NVIDIA is over their only real competitor for GPUs and accelerators. Unless, of course, you count Intel. Intel's chips do tend to run a little hot. And on top of that, NVIDIA is already in a massive position of power, having held around 80% of the market share of GPUs over the last 3 years, with AMD taking the other roughly 20%. So here's exactly what I'm worried about. NVIDIA could end up with a real monopoly on the entire AI market. If developers want to use CUDA or the over 4,000 AI and software libraries built on top of it, they'll need to be on NVIDIA's hardware. And if different vendors want to run NVIDIA's hardware, they'll be locked into their software stack as well. And yes, I am a big fan of NVIDIA's entire tech stack, and their stock is one of my biggest holdings. But nobody should want a company to have a monopoly on what could be one of the most impactful technologies we've ever seen. But don't just take it from me. Here's a quick clip from a recent episode of the All In podcast, where 3 incredibly sharp tech investors share exactly what they're waiting for before they see NVIDIA as having a total monopoly.
I think what's really interesting here is this is a really important moment where that design, that Grace Hopper design, which is basically a massive system on chip, it's an entire rig, it's a GPU and CPU and memory and interconnects. This is like them going for the jugular. And this is what's crazy in a moment like this, that is basically them trying to create an absolute monopoly. Because if you have these rigs, and these rigs are the most capable for learning, and you have their SDK CUDA, which is becoming the de facto software layer now that you use to write to their H100s or Grace Hopper when it's available, and the A100s, that could create a level of lock-in that I think people should be thinking about. So if you're the hyperscalers like Amazon and Google and Microsoft, what is your reaction to this? If you're Facebook, what is your reaction to this? And I think it's really important because if these guys continue to innovate at this scale, you're not going to have any alternatives. So if NVIDIA continues to drive this quickly and continues to execute like this, it's a one and done, one company monopoly in AI at the hardware layer. And I think that they're ready to go for the jugular here in what looks like the most important market that's emerged in like
What
the
do you
last
think about the
decade.
valuation, Chamath, trading at 200 times or 50 times EBITDA or whatever it's
I'm in
trading
your
at?
camp. There's this principle in capitalism, which is in order to grow like that, you're generating so much profit that competitors look at it and say, hold on, you don't deserve that much profit. I'm going to take some of that.
Your profit's my opportunity. Your margin's my opportunity.
I think that your margin is my opportunity is exactly what happens. So I think what I'm waiting for, Friedberg, is like in the next 2 quarters, if AMD, Facebook, Google,
Intel.
Microsoft, and Amazon don't announce something substantive, there's a very good chance that NVIDIA runs away with this. And I think that that's very problematic. But in that case, that price is cheap. My bet, though, is that I don't think that that's going to happen because it's just too important. So my bet is in the next 2 quarters, you start to see some real action so that folks start to have to balance their forecasts where it's not just 100% NVIDIA, but it's NVIDIA plus, plus, plus. It would be pretty derelict of these hyperscalers to just throw their hands in the air and just give the whole market to them. And it would be derelict of AMD. AMD is a great memory solution, but they really don't have a deterministic AI chip. And I think that Lisa Su needs to act decisively here and build something, announce something, buy something, but she needs to be really aggressive here.
So in my opinion, Lisa Su didn't really have the answer they were hoping for. That means it's up to Facebook, or Google, or Microsoft, or Amazon to come out with products that chip away at NVIDIA's massive ecosystem, at least for specific kinds of workloads. By the way, it's not just NVIDIA's DGX H100 GPU systems, or their Grace Hopper superchip, or even their insane networking technologies that these hyperscalers need to compete with. The announcement that I think everybody is sleeping on is NVIDIA's modular MGX server platform. This one design allows for many different configurations of NVIDIA's GPUs, CPUs, and DPUs to go after many different data center verticals like cloud services and gaming, high-performance computing and data analytics, digital twins for manufacturing and robotics, telecommunications, and of course AI training and inference. And because NVIDIA will support multiple generations of hardware in these same form factors, they'll be locking in these data centers for years and years, because the cost to switch away from this ecosystem would be too high. That would make NVIDIA incredibly sticky and entrenched as the market leader. And finally, could all these things really add another $1 trillion to NVIDIA's market cap? Well, with how big the AI and accelerator markets are becoming, it's really not out of the question. I'm not saying it'll happen anytime soon, but in my opinion, they're clearly already on that path. NVIDIA really is going for the jugular here, especially when it comes to companies like AMD and Intel. And we're about to see which other companies are willing to stick their necks out to compete, and which ones will end up burying their heads in the sand. But there's one more huge disruption that you need to know about, so make sure to check out this episode next. And if you feel I've earned it, consider hitting the like button and subscribing to the channel. That lets me know to put out more research like this. Either way, thanks for watching, and until next time, this is Ticker Symbol U. My name is Alex, reminding you that the best investment you can make is in you.
So let's go ahead and get started. There's incredible interest in AI across the industry, and this is also, when we look at it, AI is really the defining technology in AI across the industry, and this is all.
It's pretty clear where NVIDIA's priorities lie these days. We're here at the Computex booth of one of their partners, Gigabyte, and this is the entire gaming showcase. That's because they, like the rest of the industry, understand that the future of computing lies in the data center. That is where the Grace superchip comes in. Under each of these gigantic heat spreaders are 72 of NVIDIA's Grace CPU cores connected together using what NVIDIA calls the NVLink chip-to-chip interconnect for a total of 144 cores. Except that's just one of the nodes. This server from Gigabyte accepts not one, not two, but 4 of these modules in its 4 separate nodes. That is an absolutely mind-bending 576 cores in a 2U server rack. But these are not the types of CPUs that you have in your gaming PC at home. Those processors, from the likes of AMD and Intel, are based on the x86 architecture. So, similar to what Apple did with their M series, M1 and M2 processors, NVIDIA is making use of a different processor architecture called ARM. And we actually did get permission to do this. You're going to be taking a closer look here. Oh, it doesn't look much like it, but this is the same style of processor that you might find in your phone. ARM processors have a lot of advantages. First and foremost being that they're typically more power efficient thanks to their relatively lightweight instruction set. So much so that NVIDIA claims these Grace CPUs have twice the performance per watt of the latest x86 chips. But the disadvantage is they also require software, like your operating system and all the programs you need to run, to be coded and compiled specifically for ARM. Now, for the PC market, because 86 has been the standard for so long, it's difficult to justify switching over to ARM. It would cost you so much in terms of backwards compatibility. But in the data center, the types of customers who are going to buy a processor like this are usually developing their own software anyway. Like, let's say Google, to run the algorithms that power Google search, or YouTube recommendations. For them, switching over to ARM isn't as big a deal, and in fact, companies like Amazon, who are developing their own ARM-based CPUs, are already doing it, and very effectively. I mean, hey, if my next gaming CPU could be half the power draw and the same performance of my current one, I'd be stoked. But this is even better. Imagine if instead of one computer, you're talking thousands or tens of thousands. The savings start to become so large that it's less a question of, can we afford this migration, and more a question of, can we afford not to make it? Now, I didn't ask permission for this part, but nobody seems to be stopping me or even really paying attention to me. So let's take apart Grace Superchip. On each Grace Superchip is up to 480 gigabytes of LPDDR5X ECC memory per CPU. And what's really cool is that that can actually be accessed by either CPU over the NVLink interconnect. That's how fast this new NVLink is. The only downside to this approach, since we're making comparisons to Apple, is that just like with your M2 MacBook, you better decide how much memory you want in your server right at the time you buy it, unless you want to replace the entire compute engine while you perform a memory upgrade. Given that the rumored price of their H100 GPUs is $100,000, I don't even want to know what this thing costs. But hopefully you get a bit of a discount when you buy it together with the Grace Superchip CPU. Let me show you this. Can't believe they're letting me take this off the wall. Okay. Success. We have dropped nothing important so far today. This is Grace Hopper. On the one side, we've got the same 72-core Grace ARM CPU that we just saw, but on the other side, the shiny latest NVIDIA H100 Hopper GPU. You can probably see where this is going. Just like with the dual CPU Grace module, these two are also NVLink chip-to-chip interconnected, meaning that the CPU and GPU have a whopping 900 gigabytes per second of theoretical bandwidth to talk to each other. So for some perspective, a GPU using a full 16-lane Gen 5 PCIe slot would only have about 64 gigabytes a second of peak throughput. That is 1/14th as much as this. And that's far from the only mind-bending number that this thing is capable of. While the CPU side uses the same up to 480 gigabytes of LPDDR5X, for the GPU side, they need much faster HBM3 memory that runs at a whopping 4 terabytes per second. It's about 4 times faster. That's why the memory needs to be right on the package, right next to the GPU. Now, all of that is great and cool and all, but HBM is very expensive, and as you can see, there's only so much space here. So the H100 only gets 96 gigabytes of memory. Okay, yeah, for gaming, that certainly sounds like a lot, but AI data sets can involve terabytes of data, so it can get used up very quickly. That's where the interconnect comes in. It allows the GPU to access the CPU's memory in a very direct and transparent way, giving the H100 Hopper GPU a functional memory capacity of nearly 600 gigabytes. In practical terms, according to NVIDIA, that puts Grace Hopper anywhere from about 2.5 times to nearly 4 times as fast as an x86 CPU paired with their last generation A100 GPU. And where things get really wild is in the data center. With an NVLink switch system, you could connect up to 256 GPUs together, giving them access to up to 150 terabytes of high bandwidth memory. I mean, you guys remember that crazy Mars lander demo that we showed off on the petabyte of flash array? You could load that entire 1 billion point data set into memory in that configuration and still have 50 terabytes to spare. Now, this module, a little bit more power hungry than the dual CPU version. 1,000 versus 500 watts per module, but I mean, that's for CPU, GPU, and RAM for both of them. And with this kind of performance, of course, not everybody wants to move to an ARM hybrid CPU-GPU architecture, so NVIDIA is still going to be supporting their old-fashioned configurations, be they H100 GPUs in a PCIe form factor, or their HGX H100 with up to 8 SMX5 GPUs. Each of these draws a massive 700 watts, making an RTX 4090 look like a child's plaything, and supports NVLink between these GPUs and NVSwitch to additional servers. This is the G593-SD0, and Gigabyte was very proud of the fact that they are the first NVIDIA-certified HGX H100 8-GPU server in a 5U chassis. Man, that is a lot of compute in a tiny space. Jake's in my ear here telling me I should pull one of the power supplies, but if you've noticed it getting darker, it's because they're actually shutting down the pre-show and they're trying to get us out of here. But there is one more thing that we wanted to talk about. Where'd it go? Dang it, Jake. No, oh my God, oh my God. Okay, well, this is, no wait, this isn't the one I wanted. Okay, it's a ConnectX-7. This is an even faster network card, so this is probably the first NVIDIA-developed Mellanox network card, given that the acquisition was, what, about 2 years ago?
Yeah, ConnectX-6 was already out.
Yeah, but NVIDIA didn't buy Mellanox just to make faster ConnectX cards. No, it was to make these. This is a Bluefield 3, so it has networking on it. This is a 100 gigabit one, but it's available at speeds up to 400 gigabit. But what's really special about it is that it has up to 16 processing cores on it. Why, you might ask? Well, just like in the old days when we started offloading TCP/IP processing to our network cards rather than having our CPU handle them, this is going to offload all kinds of interesting things, like encryption of your network traffic, or say, for example, managing your file system. Because when you're someone like an AWS and you want to squeeze as much revenue as possible out of every CPU in your data center, you don't want it handling stupid BS that you could just offload to your network card. So the idea here is to free up CPU resources that can be leased to customers by putting them onto the network card itself. And this is especially true for software where the developer sells you a license per core. That's why even though these are going to be wildly expensive, a lot more than the 4060 Ti, NVIDIA is going to sell shed loads of them. Just like I sold this Segway to our sponsor, Pulseway. Are you sick of feeling like a prisoner chained to a desk managing IT systems? Unleash your inner IT hero with Pulseway's remote monitoring and management software. Pulseway's platform gives you the power to manage your IT infrastructure from anywhere, even from the comfort of your own couch. And with real-time alerts and notifications, you can be the first to know about potential issues before anyone else on your team. It's accessible through whatever device is close to you thanks to their convenient apps, allowing you to control your IT systems like a boss, even if you're lounging in your PJs. So say goodbye to the boring routine of IT management, and hello to the fun of being an IT hero with Pulseway's advanced technology. Don't wait. This is your chance to become a legend in the IT world. Just try PulseWave for free today and experience the power of simplified IT infrastructure management. Click the link below to get started. If you guys enjoyed this video, why don't you check out, the petabyte of flash.
That was a good one. Well, we're at the gigabyte booth. Come on. The G-Raid one.
Yeah, G-Raid.
Oh, actually, no. New Wannick. New Wannick 3. Oh, Wannick 4, I mean. Damn it.
Somehow word got out to the Framework team that I was heading to Cooler Master to cover the case that they built in collaboration with Framework. So imagine their disappointment when they all showed up and found out Cooler Master wasn't demoing it. Fortunately, Framework CEO extraordinaire Narav showed up with a care package that has both the Cooler Master case and the reason that I need it. You see, I am going to be the first person outside of Framework to upgrade my original Framework laptop, which started its life as an 11th gen Intel machine, to Ryzen 7000 mobile. All I need now is somewhere to perform the surgery. Oh, and this segue to our sponsor.
Nexigo. Whether you're in need of webcams or accessories for your VR device, Nexigo has a great selection of products to choose from. Learn more about them at the link below.
I have to know, for the team at Framework, how painful was it watching me last time screw up like half of this upgrade process?
That hurt to watch.
You do understand I've still looked at none of the documentation, right?
Fully expect that you've never read documentation in your life.
But, hey, now that's not fair. But you are here to make sure nothing goes wrong, right?
Yes, definitely. Okay. First, you need a screwdriver.
Oh, I got you. There.
Never leave home without one.
Yeah, absolutely. I mean, did you see me taking apart the new NVIDIA Grace Super Chip server with this thing? Oh boy. Don't judge me. Look, from a waste standpoint,
it's true, yeah.
I should keep using this dented chassis.
Until it melts or
disintegrates
somehow.
That's what I'm talking about. And the fact that I can keep using it with modern hardware, that's the whole point.
It is. And if you build a LTT hammer, you can bang the dent back out.
We may actually do that. For the uninitiated, this is one of the coolest things about the Framework laptop, the modular I/O. You can have USB-C, USB-A, HDMI. You can have 4 HDMIs on your laptop if you really wanted to. I don't think you could drive them all at the same time. But
you can drive 3 of them. Actually, you can drive all 4 if you're not using the internal display on Intel.
Okay, all right, fair enough. He's just going to correct everything I say.
Every sentence is going to have a correction.
It's good because the audience likes seeing me taking down a peg.
Nope.
What do you mean? Okay, hold on.
Yes, good.
In fairness to me, it's been a while since I've done this.
Wait. You have to power it off first.
Why?
Well, technically, I guess you could leave it on, but it's bad for your OS.
See? Permission.
No, God.
Hold on, I'm not going to break the ribbon cable. I remember the ribbon cable.
Good, okay.
How cool is it that this is magnetic, though, okay?
It's like a fidget toy.
I mean, you heard it from the CEO first. This is a fidget toy. How much are you guys enjoying watching me bug him?
Our head of IT is looking at this thinking like, oh my God, what's happening to this laptop?
So that goes up a little something like that. And then there's a little pull tab here. Boop. Now my keyboard and trackpad, both of which are user serviceable, are removed. Well, let's just start removing things. The SSD's got to come out. Now, I'm gonna remove the Wi-Fi card.
Yes.
Let's put that with that.
Those are actually the same, so that's okay.
They're color-coded, right?
Yes.
Yes. Isn't that cool? Oh yeah, and there's extras, just in case you are me and you lose some. I didn't tell you this, but aside from wanting to upgrade, I've had an issue with my display.
Okay.
Every once in a while, it just like, does stuff. So I figure I probably screwed up something here.
You might have by scratching around like that. Possibly it's a graphics driver issue and you need to update your drivers. That's one possibility.
Okay. Well, one way or another, we're gonna disconnect this.
Yes, if you are not careful with the EDB cable, you might have messed up something in there.
Cool. Now, I'm gonna pull out this daughter board thing.
Yes.
Just relax. I'm gonna release the latch, sort of.
Actually, you want to disconnect it from the other side. Okay, that also happened. It came off. It'll probably go back on.
Oh, speakers.
Yes, and you've got 2 more cables.
No,
okay, won't spoil it.
Don't tell me the answers. Okay, we've got the, whatever the crap this is.
Yeah, you should use a plastic spudger, not a metal screwdriver for that.
You say there's another one.
Most important one.
I wouldn't have noticed that, so... Oh god, the battery's still connected. Yes. Well, there's your problem. Should have done that one first, realistically.
Oh, it's actually safe to disconnect the other cables while the battery's still plugged in, as long as the LEDs aren't blinking.
Oh, okay. Why do the LEDs matter?
So the LEDs are indicating that the main board is still powered, and we've designed this in a way that if the system's open like that and powered off, it'll shut itself off after about 5 or 10 seconds, and then you can do anything safely.
So it's like chassis intrusion, but in a way that's not...
Yeah, that's helpful.
And then the best way to remove the main board is to just flip it upside down.
Oh my god. Okay, that'll work. Don't do that, anyone, please.
Strictly speaking, there's nothing else I need to do.
Nope, that's it.
But I do want to investigate my EDP cable. So we're going to pull off my bezel.
Yeah, you should open that further. It's easier to take the bezel off.
Oh, got the tech tips here.
Framework tech tips.
Okay, so what did I do?
So
I think I routed this wrong.
Yeah, you have to be careful. There's a routing channel here, and you want to route it through there, and you have to carefully route it around the hinge in a way where it doesn't get pinched.
Yeah, not bad. You've built a laptop before.
Build a few thousand of them, sure.
We got to make a big decision. Do we want to put the AMD board in now, or do we want to put this in the Cooler Master case? Cooler Master's been generous enough to lend us their booth. Why don't we put it in the case? Can I call on the case PM to come help me with that?
Esther, do you want to go in the video, do the case? It's okay, they'll give you direction for what to do.
Okay. He told me I don't need to speak.
Oh, that was a lie. Why would we put a microphone on you if you don't have to speak? Who designed the case then? Cooler Master or Framework?
We designed together.
Oh, really?
Yeah.
Okay.
It's a very useful case, so if you got our laptop and you need to replace the motherboard, and then you got an older one, so you can place it on this magic box.
Okay, now hold on a second. What's that?
A rubber stand with some mount screws on
Oh,
the
cool.
bottom side.
So you can mount it on the desk, or use the screws that are in here, and then what? Put them in the keyholes and mount it to the back of a monitor anywhere you want?
Yes.
Now, tell me something. The laptop itself only has an intake on the bottom, but the case has an intake on the back and the front. Why is that?
So we try to make the intake more, so you can release more heat.
Oh, so it's just to improve cooling.
Yeah.
Now your job is very simple. If I do anything wrong, you have to stop me.
Okay.
Do you think you
Yeah,
can do that?
I can do it.
Okay, perfect. Whose idea was it to do a clear front?
We kind to put our product line to be transparent to see the reuse modules.
Cool. Oh, and it's got labels and stuff too. NVMe, Type-C, RAM slots. Very cool. That's going to be awkward if you guys ever change the layout of the board. Is the layout of the board ever going to change?
Not enough that it would shift that around.
Okay, and it just goes in like that and the whole thing just like fits by friction, or?
You still need to screw on.
You sure?
Yeah.
Because it seems to be in right now.
Yeah, because our design is great.
Yeah, okay. Oh, I get it. The screw holes have what are called screw bosses. And these actually push down on the motherboard everywhere where a screw goes into the top of the chassis, securing it with no motherboard screws at all.
Yeah.
So if I wasn't busy chit-chatting, I could do this whole operation in like 2 minutes.
By yourself, yeah.
By myself. You sure? By myself? I mean, did you watch the video where I upgraded my laptop?
Yeah.
So now I just do up all the screws?
Yeah. And actually, we can put if you want to abandon this laptop, you can use the audio card to insert here. And also for the Wi-Fi card, you can put here.
Oh,
Yeah.
we also didn't put any RAM in it.
Yeah.
Now, you included the screws for those cards, but I couldn't help noticing that there's no antenna for the Wi-Fi card.
People can use the external antenna from here, or they can also buy our antenna module as laptops in our marketplace.
But you don't include it in the case?
Yeah, we don't include it in the case.
Okay.
Yeah.
I probably would want that included in the case, but okay. So right now, I have no audio interface unless I buy another one then.
You can.
Right, but I still need my laptop.
Okay, so you can use our audio. We got audio card.
Oh, right. I could just get an audio USB-C module. I also don't have that though.
You don't have that card?
Not right now. Now all we need to do is install RAM, SSD. I gotta say, aside from that I didn't order some of the components that I need, that is pretty much the easiest computer I've ever built. We're done now, right?
Yeah.
I didn't miss anything this time?
Not for this time.
On a laptop, obviously your power button is wired up to the motherboard somewhere. Where's my power button?
Power button here. We highlight in orange.
So basically, it's a little piece of plastic that presses a button on the main board itself to power it on and off. USB-A, USB-C, yeah. HDMI, and instead of putting in my second USB-C, I'm actually gonna borrow this 2.5 gig module from Nirav. I'm gonna try. Sure, there we go. Now we have display, USB, and Ethernet. We just gotta find somewhere to power it on. Wait, power. Oh, right, USB-C, that makes sense. Took me a sec.
It's upside down.
Oh.
This way.
The last step is to power it up. Cooler Master was kind enough to lend us their Motion 1 chair demo here, so can I just start unplugging things? Okay, fantastic. Now, we borrowed a DisplayPort module from Nirav, because of course he has one of those. Why change your cable when you can change your I/O? The light's on, right?
Yeah, light's on. It needs some time.
There we go. Yay! Okay, you guys are selling it a little hard here. You can't blame them for being passionate about what they do. And there's that Windows update. I just want to shut the thing down. More updates. No, it's time for the big show. He was so like, oh no, I can't let you have the AMD motherboard. Oh, the firmware's not ready. Before we started this video, oh no, the other media will be mad that I let you have the AMD motherboard. So he made me promise to say, it's because I'm an investor that I get to play with the AMD motherboard.
If you want to provide $200,000, we will give you an AMD mainboard. Anyone in the world out there.
I wouldn't be surprised if someone is crazy enough to do it. You gotta be careful with stuff like that. Now, in theory, I don't have to do basically anything here, right?
You reverse what we just did and put it back together.
What exactly am I putting in my computer though? Is this Ryzen 7, Ryzen 9?
This is the Ryzen 7040 series, so this year's latest platform from AMD.
This is very similar to what you're seeing in handheld gaming systems like the ROG Ally, which, I mean, I know that you guys have never built the Framework 14 as a, oh, it's a 13, isn't it? Framework 13, sorry, as a gaming machine, but...
Yeah, the gaming performance is there, especially with 2.6 of RAM.
I am so excited. Wait, oh, you already put the RAM in for me.
Preloaded
oh, that's
for you.
Boring. 16 gigs of RAM, that's it?
I'm sorry. This is also a Ryzen 5. This is not the Ryzen 7 version because we gave the engineering team all the good main boards.
So if I understand you correctly, people have to give you $200,000 and you're gonna give them a half-baked Ryzen 5.
Yes, it's great. Ryzen 5 is really great though.
You know, for an evil supervillain, you present very nicely. Tell me something, did you guys completely reuse the same thermal solution?
It is almost the same. The fan's the same, the heat pipes are the same. The heat spreader is actually different to match the die.
Got it, because it's...
The height's a little different, the XY's a little different, and the power regulation around it is different.
I have to confess, I debated you in here a little bit because I wanted to ask some questions on behalf of the community. Starting with, why the hell did this take so long?
When you're a startup, as you know, having been a new company many years ago,
yes,
it is hard to get attention from the right people. You have to build credibility, you have to put in the work, you have to put in the hours, and people realize that you're serious, people see that you're doing something important, people see that the community is getting excited, and then we start to unlock better ability to do more. And so ultimately the question is like, why hasn't Framework done anything?
Yeah, why haven't they done anything?
The answer is...
He's asking himself the big question.
Why haven't we done anything? No, the answer is either we don't have enough people, we have to focus, we really, really have to focus. We have more ideas than people. We don't have the money. Sometimes people give us money to help us out, which is great. Or we haven't been able to get the right connections at the right partner to do the thing that we wanted to do.
So I got debated. You lured me in here to ask for more money.
I'm not gonna say no.
He actually didn't say no.
I didn't say no.
Okay, I guess I'll just screw down the motherboard first,
You
right?
can, yeah.
Okay.
You should make sure you're not pinching any of the cables under the main board. Okay, but there's like one there and one there.
Gee, relax. You know, for someone who didn't even bring me the new higher capacity battery, you're being awfully critical.
I was going to ask about that, actually. If you wanted one, I could have brought one. Same with the panel, actually, the matte screen.
I'm okay with the glossy screen.
Yeah.
I like seeing the outline of my my keycaps.
Okay.
Okay, then I get my Wi-Fi over kind of here-ish, right?
Yeah, you can put them through the routing channels, these rubber channels. Also, we have a new Wi-Fi bracket that's a lot easier to use. This is the old one.
Oh, okay, cool.
Which I
now
did
you
not
said
bring.
the label's not right on this. Is it Wi-Fi 7?
It is Wi-Fi 6E, but I just reused a
you
case that we had on.
Really? You're going to give me an Intel box and you're going to give me a MediaTek Wi-Fi module?
It's an AMD MediaTek combo RZ616 module, co-branded AMD MediaTek. So the trick to this is you keep your finger on it while you're putting it in there.
Yeah, well, hold on. The first trick is that I have to find the screw.
Yeah.
Because I think it's stuck to a magnet somewhere. Oh, no, we got it. Now I'll just plug in my display and hopefully not ruin that this time. I kind of feel like I should have put this ribbon on earlier.
Well, it's really
Why didn't you warn me?
No, I told you shouldn't have taken it off from this side.
Why didn't you do a better job of stopping me?
Sure.
Oh, okay, it's labeled.
It is labeled. Actually, it doesn't.
AUMB.
Both sides the same, but we label it anyway.
It looks like I'll have to wait a little bit to actually have a secondary computer made out of my main board, but this is such a cool concept. I mean, you guys said before, yeah, you can reuse your old main board for something, but I feel like over the last 2-3 years, that sort of aspirational dream has actually come true. Like if you buy a framework today, whether it's 13th gen Intel, you wait a little bit, you get the Ryzen one once it's not $200,000. That is a very usable machine by the time you're pulling the motherboard out of it, putting it in a cool little chassis like this, and then repurposing it for a media PC or for a retro gaming box.
Definitely.
Or whatever else. Not to mention that on the Intel side, you've got support for Thunderbolt, so you can even hook an eGPU up to the thing if those ever get affordable. Wait, you guys should do an eGPU.
We did show a demo of one at our event, a concept demo of one.
See, they were all like, no, you have to come to our event to see everything. And I was like, look, I'm not coming to the event. And they're like, well then, we're just not gonna bring everything. So I didn't even know. I actually didn't watch the event.
Are you? Okay.
So I did not know that.
That's fair. I didn't watch your last video either.
It's amazing how quickly this relationship went from let's support each other to do great things in the PC industry to purely adversarial. Record time, I think. No, hold on, I'm not done yet.
No, that's right.
That's power. I got my cable routed.
So you have to be careful in this.
Yeah. You have to be careful, Mom. So now all I gotta do is put my keyboard trackpad back on here. I really like this cable. The way that it kind of is nice and long and you can kind of, you know.
Yeah, this is called.
Oh, I think I just powered it on.
I think, yeah.
Is that okay?
Yeah.
I mean, that's good, right? So the blue light means powered on, right?
No, actually, that blue light's a debugging light, so I'm not sure why it's on.
Oh, sick.
That's not on the actual shipping systems. That's for debugging.
Oh, okay. And then I have more flashing red lights. In fact, there's flashing red lights all over the motherboard.
But you are powering on.
Oh, but I'm powering on,
Yeah.
so I should maybe cover it.
This back together.
Are you sure you'd like me to cover it now?
Yeah, you're good. Well, yeah, no, you're good.
First boot outside of the lab, AMD framework laptop.
I actually don't know the answer to this, whether this is going to boot. So this is genuinely a surprise.
I had to be extremely, let's say, assertive to get him to let me show you guys the AMD motherboard. It's really, really not done yet. There's a ton of firmware work to be done. Like the thing with going from Intel generation to Intel generation is two things. One, he didn't say this, I just know this. Intel has a lot of structures in place to support their OEMs that AMD doesn't always have analogs for. Number two is going from Intel generation to Intel generation. There's a lot less to rework, but it turned on anyway!
I'm genuinely surprised, happily, that works.
Now, he made me promise not to go any further than the login screen. I didn't go any further than that on camera. Can you tell me why I can't go to the desktop?
The firmware and the drivers are definitely not baked. Also, I didn't bring any drivers, so you're running Intel drivers on an AMD mainboard right now.
What could go wrong?
Neither AMD or Intel is going to give either of us the answer to that.
I'll tell you what. Here, hold on. I'm altering the deal. Pray I don't alter it further. We go until, wait, hold on.
Okay.
Until the slightest abnormal behavior, and then the video hard cuts. So we won't show any of it.
Can't do it.
You can't do it?
This is it.
What do you mean can't? My keyboard doesn't work? No, my keyboard does work.
Keyboard does work,
so I can do it.
But you can't log in right now. Actually, you probably can't log in.
Yeah, I probably can. He said it.
No, I probably can't.
Oh, can't? You think I can't log in? Do you think my fingerprint will work?
No, your pin is required, but your pin can't be used because your pin is no longer available.
Why did you break my laptop?
I'm sorry.
Okay, but actually, hold on a second. What does all this mean?
So the key to all of this is that when we actually ship this, we have guides that we publish, step-by-step, super easy to follow guides.
Got it.
If you follow it step-by-step, everything just works.
Got it.
If you do this, it happened to get this far, which is great, actually. So I think we're stuck at this point because you're not on a network because you don't have the Wi-Fi drivers, so you can't connect your Microsoft account to log into Windows.
Intentionally. What's the ETA for this?
So we are starting shipping in Q3. Batch 1 is in Q3. And actually right now we're all the way out in Q4. So we've got a ton of demand for AMD.
Oh, I see. So if people want to get one this year,
they do probably need to order, yeah.
Okay. And full disclosure, I am an investor in Framework Laptop Inc. or whatever the company
Framework
is called.
Computer Inc.
So you make ink?
We get asked a lot to make a printer. So.
Man, this might not be just throwing my money away after all. And this might not be throwing away this segue to our sponsor, Squarespace. If you need to build a brand online, you need a website. But Linus, I just learned how to turn the little flashlight on in my phone. How am I going to build a whole website? Squarespace can help. Squarespace is your one-stop, no-frills, all-in-one platform for expanding your presence on the internet. Squarespace lets you build beautiful websites, engage with your audience, and sell anything and everything from products to content without needing to spend 4 years getting a website building degree. We love Squarespace so much that we use it here at Linus Media Group. Its custom templates make it easy to stand out with a plethora of themes and customization options to fit your needs. You can maximize your visibility thanks to a suite of integrated SEO features, and there's also analytic insights to help you optimize your performance and see what's working well and what needs tweaking. So get started today and head to squarespace.com/LTT to get 10% off your first purchase. If you guys enjoyed this video, you might enjoy the last time we hung out and showed off the Framework 16, which, okay, take this in the kindest possible way, makes this thing look decidedly last gen. That thing is amazing. This is Adam. He's relatively new here, which makes it all the more impressive how much stuff he's managed to steal from the office. What? There's no way that you bought a shit stack. It has an inventory label on it.
I want it.
1 jerry-rig everything knife.
Criminal scum.
Stolen?
No, those are given away.
Yeah, by who?
Now all I gotta do is give one to everyone on my team.
Did you hear him? He said I might be hard-pressed to find these cable ties!
I purchased those. I have the bag.
If you steal them, they still come in the packaging. This passport? Is this even you? This Apple TV!
Alright guys, so if you didn't know, Andrew and Tristan Tate were quote-unquote charged with the crimes that they were accused of, but from what I understand, it's not like fully charged and they're going to jail instantly and it's over. It's not like that. They still have a chance to face trial and the judge can dismiss these charges, which, you know, is a very, very weak attempt to silence somebody because the evidence is extremely weak. But at this rate, over these 6 months of hell, they can't just release him, can they? They really have to stretch it out and go as far as they can possibly go. And recently, recently, after all of this BS, Andrew Tate has issued an official statement which you need to see because it's super important. But yeah, guys, leave a like on the video and subscribe with notifications for the latest updates. But yeah, just take a look at this video.
So I just wanted to have an informal conversation. I was going to put a suit on and do this formally, but I think it's better if I do this informally. Highlighting some of the things that everybody already knows about how the Matrix operates and what they're trying to do to me and what I believe is going to happen next. It's quite interesting that they are attacking me and attempting to vilify me at the exact same time, whereas real predators, which work for the media establishment, are being ousted. So it's really interesting to do a juxtaposition and do a comparison, right, between how they will treat Philip Schofield, who is confirmed as a groomer, who is admitting he has committed sexual crimes, and how they'll treat me, a man with no convictions and no admission of sexual crimes. Look at the differences in the headlines. Look at how soft they are in their interviews with him.
You've had quite the week. How are you?
Look at how now, after only 2 or 3 days, the headlines are saying we should forgive him and feel sorry for him and let him off. Whereas me, who's been under constant media assault for over a year, they never let up. They never change. Someone sent me a clip yesterday of Philip Schofield saying he's going to kill himself and how sad he is.
Last week, if my daughters hadn't been there, I wouldn't be here.
Why do they keep pushing me? Why do they keep pushing me, playing the sympathy card? And all the headlines are now like, yeah, we can't keep attacking this poor man. For 1 year they've attacked me, and they will not stop. And this highlights the difference between the people who are on the side of the establishment and the people who are not on the side of the establishment. I've been offered to sell my soul very many times. I want everyone at home to understand, you do not become the most Googled man on earth, especially amongst a demographic of young men which have money to spend, without very large companies and corporations becoming extremely interested in you. I've been offered $50 to $60 million by companies I'm not going to name. All I had to do was shut up. Shut up, take the money, wear the stupid hat, wave around the stupid drink, whatever it is, and continue to agree with whatever the Matrix says, regardless of my own personal feelings, my personal views and beliefs, and just push it on the minds of young children. And I refuse to do that. I refuse to sell my soul. If I would have sold my soul to a large corporation, and then this attack happened, which I very much doubt this level of Matrix attack would have even happened to me, but if it did, then this large corporation would speak to the media, and the media would be treating me like they treat Philip Schofield. They wouldn't be treating me as an enemy, they would treat me as an ally. All I had to do was sell my soul, and I refused. The recent BBC interview that took place, I don't think most people understand genuinely how snaky that interview was. The reason I had to destroy her so ruthlessly is because of how the interview was set up. When I was in jail, the BBC was constantly trying to get me to give an interview over the phone, and I refused. When I left jail, the BBC begged me for an interview, daily, begging me. And for 3 months, I refused. Eventually, once I understood, after my 3rd month of house arrest, what the Romanian government is going to do to me, which we're going to discuss shortly, I thought now would be a good time to get an interview. BBC begged me, saying that Romania has one of the most corrupt justice systems in Europe, that there's serious problems with the case, lots of evidence that's been leaked shows Andrew's innocent, that Andrew's side of the story hasn't been heard, that we're interested in fair and unbiased journalism, that we don't want to come there and do a hit piece, we want to speak to him and try and find out the truth of what's happening. In fact, we're going to send you the questions we want to ask in advance. I'm not a coward. I never ask for questions in advance. I don't care, because I'm a professional, and I will destroy anyone instantly. But they sent us a list of questions, which was shown to me, and I was like, well, those are actually interesting questions. What's my mental health like? What's Romanian jail like? What's it like being in a courtroom where everyone's speaking a language you don't understand and having your liberty deprived of you? I thought, this is going to be an interesting interview. I agreed. The BBC, all nice smiles and all lies, sent us this entire spiel, turned up, turned the cameras on, sat down, and attacked me.
Have you ever put any and applied any psychological control on any of the women you dated?
No, and I respect women. This idea that I'm so much smarter that I can hypnotize somebody, I think is extremely misogynistic idea. I think your idea is misogynistic to believe that women don't have their own free thoughts and free minds. They attempted to sucker punch me. They attempted to shake my hand and knock me out with a sucker punch once the cameras were on, to hit me when I was off guard. They expected me to be off guard, ready to talk about my mental health, and hit me with these questions and me make a fool of myself, unaware that I'm a master of Aikido. And when you attempt to sucker punch me, it simply misses, and I destroy you.
I think we're done.
Yep. Unmatched perspicacity. Just because I'm the best there's ever been, and me, with my quick thinking and nearly incomparable wit, can sit and destroy a professional reporter and her entire research team's preparation. Just because I make that look easy doesn't mean I should be forced to succumb to these unfortunate circumstances. 99% of the population, if they were tricked the way I was tricked, would look a fool on camera. They were very prepared to try and make a fool of me. But I'm the best there's ever been. Did they do this to Philip Schofield? No. Where was the BBC's outrage when Rolf Harris or Jimmy Savile were touching children? They don't care. Where's the BBC's outrage when certain other people, high level in society, members of the royal family, are caught having pictures with minors? They don't care. But they will continue to try and convince you that I am something I am not, on repeat, over and over and over again. These people are worse than disingenuous. They are worse than simply liars. They are evil. They are a club. And if you sell your soul and join the club, they offer you protection. And if you don't, they aim to destroy you, which is what they're trying to do to me. The reason I decided to give the interview to the BBC is because I now believe that the next step, and I'm going to call it, because I've called everything that's happened to me so far. Look at my old interviews. I said, stage 2, they're going to try and put me in jail. I understand that you get 3 strikes in this game. Strike 1 is they try and shut you up and discredit you, which I've just been through. Strike 2 is they try and put you in jail for no reason. And strike 3 is they kill you.
The truth is this. So I knew it was coming. I absolutely not knew it was coming because of how orchestrated it was. The only thing, and I'll state this at the beginning, the only reason I'm upset by being canceled is because I've expired one of my lives. I mean, I'd never kill myself. Don't fucking try. But, bruv, because that's what's next. That's what's next. It's scary. I'm telling you, everyone thinks I'm paranoid. Everyone thinks I'm crazy.
So it's like every single organization on the face of the planet is corrupt. This is what I say to people. I say, listen, and I'm going to say this on this podcast now because I say it on every other one. I would never, ever kill myself. I truly believe they're going to come and they're going to try and kill me on a long enough time frame because they tried to shut me up and I won't shut up. They're either going to try and put me in jail or they're going to kill me. And I would never kill myself under any circumstances ever. And the reason I say this, and I say this to people, and they go, but what can they put you in jail for? And I'm like, how ignorant are you in your ignorance to believe they need a reason? You believe it's fair. You believe I can get a lawyer and prove myself innocent. That's not how it works. They decide you're guilty long before and they find a reason why. And it doesn't matter what you do about it, you will pay the fucking price. It's not fair. None of it is. Every single system's corrupt. It actually annoys me when people say that to me. Well, just get a lawyer. Why? They can't put you in jail if you're innocent. Yes, they fucking can. And that's what people don't understand about the world. They can and they do and they fucking will. And that's what's scary. I'm going to call what's going to happen next. The Matrix is extremely angry. And they are angry because their weapons aren't working. I remain unfazed. This is the first time in history someone who was canceled became more popular than before. This is the first time in history where a full broadside of media lies for over a year across every single outlet that they control has failed. Nobody believes them. Nobody. So now what do they do? Well, I believe the UK is going to try and raise charges against me. Don't know what for. I've done nothing wrong. Something's going to appear from nowhere. In fact, I will say that I have some very high-level friends and some whistleblowers who are confirming exactly that to me. They've looked at me and thought, we have to get this guy. What's he done? Nothing. Find something. Who cares? Get some papers, move some papers around, get a judge who'll stamp them, and put him in jail. It doesn't matter that I've done nothing wrong. I also want to say that I believe the Romanian government is going to charge me. They're not going to charge me because they have any evidence, and they're not going to charge me because I'm guilty of anything. They're going to charge me because after a 14-month investigation, 6 months of arrest, which is the maximum they can possibly give me without charge, I don't think they can just drop this. Imagine they just drop this tomorrow. Oh, we made it all up. Imagine that. What choice do they have but to charge me? If they charge me, I have to go to trial. Now, of course, I still believe in Romanian justice. I really, truly believe that even with Romanian justice systems or matrix-controlled justice systems, I will be found innocent. Because I know the case file, I know what's in it. But that's going to take years. They're going to waste 1.5 to 2 years of my life, make me go to trial. Then when I'm found not guilty, it's been years. Who cares, right? Distance from event. If they drop it now, it's the biggest story in the world. They can't drop it. They're going to charge me. They're not going to charge me because I've done anything wrong. They're going to charge me because that's how the Matrix works. Unfortunately, I'm up against an enemy which I can't really, truly beat. I can't beat them. All I can do is continue to discredit them to the point where nobody believes them anymore. And I cannot do that without having perspicacious, intelligent people at home who are analyzing the situation and truly understand what is happening to me. If I have to martyr myself, if I have to some degree sacrifice my liberty and the quality of my life to highlight how the Matrix operates, how the legal system and the media work hand in hand to try and convince the populace somebody is guilty before a judge says they are guilty because they have pre-decided to say this person is guilty because of his wrong-think. If I have to sacrifice myself to do those things, then I guess at least my imprisonment is a noble one. And I'm a man. And although Romanian jail is as close to hell as you can find on planet Earth, if I have to suffer it, I will do that because I will not sell my soul. The point of this video is only to highlight and make clear the differences in how the people inside of the club are treated versus the people who are outside of the club. And also for me to predict the future for everyone to understand. When new charges come, when new countries attempt to attack me, when the Matrix unrelentingly continues to print lies about me and try to convince the world that I am a bad person, I hope it does nothing else but show the world that I am a good person. These people are liars. The people they tell you are good are not good. The people they tell you are bad are the good ones. Do not believe a word that they say. All in all, my predictions for the future are not certain. My future is certainly not certain. Whether I'll continue to breathe or continue to be free, nobody knows. But the one thing I can guarantee to absolutely everybody at home, and anybody who believes in me and my message, and anybody who listens to me speak, I will never sell my soul, I will never be controlled, and I will never lie.
Okay, impact. Let's think impact. If a person's watching this content, most of the people that are watching this, a portion is going to be those that are haters, that just want to find, like, poke at the argument.